It's a nonprofit organization located inside of the Fuller Dome on the campus of SIUE that is a multi-faith place of worship for students on campus. In addition to that, we also have programming that is in alignment with our mission to promote humanity's sacred connection to the earth and to each other. For example, last week, we had a play that a playwright came in from Los Angeles and put on a one-man play that he's been doing for 15 years that he embodies Buckminster Fuller. And we've had music, we've had lectures on anthropology, we have an array of offerings that, again, kind of are in alignment with the center's mission to, strengthen our sacred connection to the earth and to each other. So another example of that is an annual awards dinner that we have, and we give out an award for spirituality and an award for sustainability. So someone in our community who is showing leadership in either creating a more sustainable future or work in a spiritual mission that's either breaking down barriers between different religions or doing work that's guided by a spiritual mission. The Fuller Dome is a geodesic dome, and Buckminster Fuller is the patent holder for the geodesic dome. He was also a professor at SIU Carbondale from 1959 to 1974. This dome opened up in 1971, and he designed it along with his architectural partner, Shoji Sadao. Like I said, he's the patent holder of the geodesic dome, and that's significant because geodesic domes are the most efficient means of enclosing a volume of space because they require no internal structure. So it was quite a revolutionary building innovation in its time. When a man-made structure reflects the way that the natural environment is, it is aesthetically beautiful and it's also efficient. This building is significant to Buckminster Fuller's legacy for a few other reasons. His innovation for the geodesic dome came after his innovation with map making or cartography. He was in World War I, and after he got out of the Navy, he thought that we needed to design a better two-dimensional map because most of the classroom maps at that time were known as Mercator maps, and they stretched the poles so that the poles are like Greenland, for example, looks like it's the whole size of Africa practically. And he felt like, in an effort to have an accurate picture of the world in the classroom. So his map used the 90th longitudinal meridian as its central reference point, whereas the other ones used the equator. And coincidentally, the 90th longitudinal meridian also runs through the SIUE campus. His innovation for unwrapping that three-dimensional sphere into a 2D plane without distortion was that he broke it up into a series of triangles and unwrapped it. And he got a patent for that also. He called it his Dymaxion map. But the geodesic dome is essentially that process in reverse. It's comprised of a series of triangles that come together to form a sphere. So you're basically taking that 2D plane of triangles and turning it back into a sphere to create a geodesic dome. Now, so this structure allowed his whole legacy to really come full circle in that the Fuller Dome here on the SIUE campus straddles the 90th longitudinal meridian, and it also has the oceans tinted in it in blue and the land is left clear on this three-quarter sphere of a dome. And this is really a miniature Earth, so that when you're standing in the center of it, you're actually standing on the 90th meridian and you're looking out with the perspective of looking out from the core of the planet. And when you're standing in the center, the location that's directly over your head is your actual location on the planet. So Edwardsville, in the SIUE campus and the dome, is directly overhead. So you really have this sense of seeing not only your place in the world, but the world's place in the universe, in that when at night, when the sun goes down and you can see stars through the translucent dome, if you look through the clear land, like say if you look through Cairo, any stars that you would see in the star field behind Cairo would be an actual zenith over that location on the planet. So it's a true planetarium. And the term that he used to describe this architectural planetary metaphor was a geoscope.